Max, get in. Oh, we've got a little desk set up.
So rude cats, aren't they?
The neutral's hanging out, there's no earth sleeve. Straight away, two of the cables come out of the two-way. Supposed to scratch my van to bits. Morning guys, welcome back. So today me and Luke are here doing an EICR. I think the board's going to get changed and a car charger put in a few weeks' time. So we're just going to test to see how the circuits are. What I'll do is I'll talk you through step by step sort of what I'm doing, why I'm doing it. But I just want to make it clear, like, this isn't a video to teach people that aren't electricians how to do an EICR. If customers are watching, they can see what's involved and they can see that it's not sort of a fly-by thing. People shouldn't be in and out within an hour. You shouldn't be doing it if you're not competent to. And then also it's a good video for like people that are learning, up and coming sort of apprentices and electricians. They might pick up some tips. Even over the years I've changed how I do EICRs. Even some electricians, they might see it and go, oh, that's a good idea, I might use that in my future work. So yeah, I'll show you what we're doing and we'll crack on. Alright, so first I'm here at the meter cupboard and I'm just going to sort of suss out the property and see what's what. So I can see we've got a 60 amp supply, it's TNCS, so your earths are coming off of your neutral. There's obviously not an MET, all the earths are going straight into the block. I mean, it's not really a problem, but when we do the board change I'll probably run a 16mm from here into an earth block and then label where these are all going. So, I mean, this looks like it's going down to the gas. You obviously got one going up to the board and hopefully one to the water. You can see it's on a 16mm tails. So it's just good to have a little walk around, suss things out before you start testing. So we'll go have a look at the board, see what state that's in. All right, so luckily the board's easy accessible in the porch, not in a cupboard for once. So a few things just to look at straight away. So plastic enclosure, so obviously the age of the property, I'd be putting that down as a C3 combustible material, but it's not a C2 because it's not a new installation, but it's something to note down. And then also looking at the circuit, so just the cooker and the sockets are protected by this RCD, so none of these circuits are, but then same again, I mean, I'd be sticking that down as a C3 as it wasn't wired to the current regulations, and the sockets are protected, so anything plugged in used outside, that's still okay and covered by the RCD. So let's take the cover off and we'll see what the wiring's like. From taking that cover off and seeing that first bit, how it's dressed in and stuff, you can kind of gauge what the rest of the property is going to be like. So let's have a look. Right, so the cover's off. I mean, it's not awful, but it's not the neatest, so not too bad. I mean, there's a few circuits. Number one, always a good thing. There's nothing in this breaker, so that's one less circuit to test, so turn that one off. So literally we've got like a shower, a water heater, lights up, lights down, a cooker and a ring main doing the house. Straight away I can see there's 3 cables in the breaker for the ring main, so someone has spurred off to do something else local. I mean, you can do it, but I never like to see too many cables sort of bunched up into a breaker, so when we do the board change I'd like to do my end-to-ends and find what circuits are the ring, and the one that's spurred off I'd like to just put on its own sort of 16 amp or 20 amp radial, find what it's doing, and then it can be labelled. I just think it's a better way of doing it than just chucking it into another breaker. But yeah, shouldn't be too bad to test. And like I say, there's plenty of room for the board change, so should be a nice one to do. So yeah, I'll get the tester out and I'll talk you through what I'm doing. Oh, I've got a little desk set up. Probably scratch my van to bits.
Lighting, whether that's true or not, I don't know.
I wrote lights down on that just because I flipped it off.
So what are you actually typing on there now?
So I'm just setting up the whole schedule on the iPad, so literally how many circuits there are, and then I'm writing what each breaker's doing, what size breaker it is, and then I'll fill out the cable sizes. Just basically I'll fill everything I can out now, and then I'll do all my testing at the board that I can, and then all that leaves me is to go around the house, do my R1, R2s, ZS's, number of points, and then obviously look for any observations. But while I'm at the board, I just like to fill out everything I can, and I'll try and write down any observations at the board as well before I forget. But yeah, I'll fill it out and then I'll talk you through it.
Okay.
Sort of 1.5 on that one. That looks like it might be a 1mm. 6mm on the cooker, and then 2.5s in the socket. So I'll fill them out on here. Okay, so I've filled out all my information that I can at the moment, so my descriptions, my breaker sizes, cable sizes, and then all my blanks, so that's what I'll go around doing my testing and filling. So what I'll do now is I'll get my test readings from the board and I'll talk about that.
So rude cats, isn't they?
Oh,
Oh.
they're so like...
They just, get away from me.
Alright, so first thing I'm going to do is my ZE and PFC. So for my ZE, I'm going to turn the board off, disconnect the main earth, and you want to clip onto the main earth and go between your live and neutral, and that will be your ZE reading. And this is a TNCS, so the reading we're looking for is below 0.35. So I'll get that and I'll just confirm that with you in a sec. So I've got my ZE and that was 0.23, so that was well within where it should be. So now I want to get the PFC. So I want to leave the earth connected back in now because it's the fault path and you want it to have all the other paths it could take connected in the circuit. So we'll go onto the earth, live and a neutral again, and we'll get that, and then PFC. There you go, 1.02. I tell you what, it might be worthwhile the power's off quick. We'll do the IR tests so we can get the power back on from 80, and then all we have to do is turn off one at a time. So I'm going to do my insulation resistance on each circuit, and then I can turn it off, and all I have to do for my R1, R2s is I'll just turn one circuit off at a time, and then it's not interfering too much for the customer. So I've took the earth out for circuit 1, the live and the neutral, and I've linked live and neutral together just because when I send the voltage down I don't want anything to blow. It's just going to send it down, sort of both of them together. I always do it on 250 first, make sure that reading's okay, and then I'll send 500 volts down just for peace of mind. I don't like to just straight away jump in, send 500 volts down and then something go wrong. So I've already done 250, so I'll do 500 volts now. This is on the shower circuit. And there you go, 264 megohms. So anything over 1 megohm is a pass, but anything below 2 megohms should be looked at. So 264 is well above that, so that's what I'll write down on the paperwork. So I've put all them back in their terminals. Now we're moving on to the next one, which is the water heater. So same thing again, live and neutral linked out, onto the earth. I'll test it. I've tested at 250 first and that was fine, so we'll test at 500 volts. And there you go, that one's perfect. Over 500 megohms, so I'll get Luke to write that in now. And literally, we'll just do the same thing, one at a time. Don't get too overwhelmed by it. Just literally break the board down into sections, go, right, I'll do this, I'll do this. And before you know it, you've started to get through all the tests. And as you go, when you find anything wrong, write in the observations and your report will slowly build up from there. So yeah, I'll crack on and get these on and then I can turn the power back on for the customer. So we're on the last circuit for insulation resistance, and this is the one that we've got a ring main and a radial chucked into it. So what I'm going to do is, seeing as when I do the board change I'll probably stick this on its own breaker, I'll test that separately and I'll test the ring main separately so I know all the readings are okay, and then when it does go on its own breaker I know that circuit's been tested individually. While I'm at it, I'll do the IR, and then seeing as I've got the ring main all stripped out, I will do the end-to-ends, so both the lives together, get that reading, both the neutrals together and both the earths, and that's basically just making sure they're all connected in a ring, there's no loose cables and one's come out the back or anything of a socket. Make sure we've just got a good continuous reading on all of them, because you do usually find on quite a lot of EICRs that you'll have a broken ring somewhere. That's one of my pet hates. And then once we've done that, we'll do the R1, R2 as well, so I'll show you that when we get to it. Right, so just quickly doing the end-to-ends on the ring circuit. So just make sure that you zero your leads first, so you're not reading the resistance of your leads. So they're zeroed, and it's always good to, so you've got a solid bit of your crocodile clip and you've got a bit that swivels. Always just stick the two solid bits together, just so you're getting a nice strong sort of hold on that to zero them, because if you do it on one of these then it's not really a proper sort of connection. So they're zeroed now, so then literally you just go on your lives, always give them a good little squeeze, because you'll find sometimes you'll do a reading and then if you squeeze them a bit more it will come down, so you just want a nice good connection on there. Press test, so 0.55, that's done a loop, I know it's all connected, and then I'll literally do the neutrals, do the earths, and the earths should be higher because it's a smaller cross-sectional area of cable, so it will have a higher resistance. Alright, so now we're going to do the R1, R2 reading for the ring main. So what you want to do is you want to find your two separate legs, so this is easy because we've got twin and earth. Sometimes it's easier to do at a socket, but I mean I've got both cables here and it's not too packed, so I'll do it here. And what you want to do is you want to get one live from one cable and you want to link it to the earth of another, like the other leg, and then you want to get the live of the other leg with the earth of the first leg. So it's making a big figure of 8, and then you want to get that reading and then also go around each socket on that circuit with a plug-in tester and get the reading from there, and then you want to record the highest reading you get, so we'll do that now. And I've got these little crocodile clips which I find helpful. So my cables are crossed over in the board, I've got a reading from there, 0.28, and then I'm going to get this little plug socket that I can put my leads into between earth and live, and now with it on the continuity setting we'll go around all of the sockets and we'll find out what the highest reading is. Alright, so I've put the ring circuit back in the breaker. We found out the other cable that's bunched in with it does a socket by the front door in the living room. So, I mean, at least we can write a bit more of a description on the cover of the board. Now I'm going to do the RCD test at the board, and then that's pretty much everything at the board side of things, and we can go round and do sort of R1, R2 and ZS one at a time. I've got it on 30 milliamps in auto because it's a 30 milliamp RCD. Go onto your earth and your neutral. Make sure it's on the neutral coming off of the RCD and not the neutral that's on the non-RCD side. And then literally just go onto one of the circuits. You can do this from the end of one of the circuits, so if you plug the socket in you could just do the RCD testing from there, but I just like to do it all from the board, and then you're there ready to flick the breaker back on. So we'll click test, it'll trip 4 times, we'll turn it on and then we'll check our readings. One thing I like about my tester is it actually shows all your RCD readings on one screen, which is really good. At half times it didn't trip, which is what you want, so they both passed. 1 times 38.8 was the highest, and that wants to be below 300 milliseconds, so that's well within. And then 5 times the highest was 32.4, and that wants to be below 40 milliseconds, so that's a pass as well. Obviously you can see down the side it tells you if it's passed or failed, so we'll fill them in on the test cert now. Alright, so all them tests are done so far. So what we're going to do is we're going to get our R1, R2 readings. So we're just going to turn off one circuit at a time, take the live out the breaker, earth out the earth bar, link them together. We're going to use this crocodile clip, and then we'll go to the end of the circuit. So say shower, we'll link live to earth on the shower, go take the shower cover off, and we'll put our test probes on the live and earth, and that's basically going to get a resistance of the live and the earth as a big loop, and we'll write that down. And then obviously for the ZS you can calculate it by doing your ZE plus your R1, R2, but I always find you've taken the time to take the cover off of whatever accessory you're testing, so it doesn't hurt to just do your R1, R2, make sure you take your link off, turn it back on, get your ZS, and you've done both then. I know there's a bit of difference in opinion whether you should be testing live or not, but it's just part of the job in my eyes, and if you can get both readings, that's how I do it. So that's what we're going to do. I did also want to just talk about this quickly because I come across it a few months ago, and at first I thought, oh, it's a great idea. After using it for a few months, I've sort of really lost all heart in it. It's a good idea and good for certain situations, but I've found using it for testing, you just don't get consistent readings, and I often have to tell someone to go stand at the breaker and push it in. Basically, for anyone that doesn't know, you clip that onto your earth bar and you turn your breaker off, and this has got a magnet in it, and you push that onto the screw, and that makes your link without obviously taking them out, the breakers, and linking them together. But I've just found you could get like a high reading, and then you get someone to push it in on the breaker and the reading will go down, so we'll do it the old-fashioned way. Right, so the shower's linked out between live and earth at the consumer unit. I don't usually like to get it from the pull cord. I like to get it from the end of the circuit, take the actual shower cover off, because you find it quite a lot that you can get homeowners and people that don't really know what they're doing actually wire the shower up. And I've had it before where you test at the pull cord, but then the polarity might be wrong at the shower side of things, or there might be dodgy terminations. So I always find it good to test at the shower, and then also you can pull the pull cord and you'll lose your reading and then get your reading back to it, so you're checking your polarity as well. Alright, so we tried to get R1, R2 at the shower and we was getting nothing. So Luke's pulled down the pull cord, the neutral was hanging out, and there's no earth sleeve on any of them. So we're going to try getting R1, R2 here. If we don't get, well, if we get it on the supply side, then we know the cable from the board to here is okay, and it's an issue with the cable from the pull cord to the shower. So that's something that we can put down for further investigation on the report, because also at the pull cord you've got old colour cables, but at the shower you've got new colours, so there's obviously a junction box somewhere. Maybe they've not connected the earths properly, so we'll check for that now, and if that is the case we'll write down on the report that that's something to look at when we do the board change. It's okay from the board to the pull cord, but there's definitely an issue from the pull cord to the shower, so that's something we can note down. The pull cord looks like it wants to be re-terminated anyway. Poor terminations at the shower pull cord, and no CPC sleeving. Alright, so one thing I like to do with showers and cookers is just a little bit of Ohm's law and see if it's on the correct size breaker. So for this shower, we've got, it's an 8.5 kilowatt. Excuse my weird writing. So if we go to Ohm's law, you've got the triangle, you've got P over I times V. You might remember that if you're doing your college courses at the moment. So P equals your power, I is your current, and V is your voltage. P, we've got 8,500 watts. We want to find our current so we know what size breaker it's on. So we divide P by V. So 8,500 divided by 230 volts, and it comes out about 36 amps. So it's currently on a 32 amp breaker, so it might be something to note down on the report saying it might want to go up a size breaker. It's not showing any signs of damage, the client's not complaining about it tripping, so it's only a little bit over, and I mean it might not be using that full power to start the shower up, so it might not be too much of a problem, but it might be worth just noting down on a report. But you can do the same for an oven. You could find out, I know you might have a 10 kilowatt oven or a 10 kilowatt shower, and you divide that by your voltage and you can find your current, and you can just double check that it's on the correct breaker it should be. Alright, so we just jumped up in the loft because just for peace of mind, want to check out, see if there is a junction box for the shower. Yeah, we found one, so we're going to open this up and check, because I've got a feeling there's an earth probably come out, and that's why we're not getting the reading at the shower. So let's have a look at that. Alright, so we wasn't getting an R1, R2 reading at the shower. We found our junction box in the loft, and as you can see, some plonker has wired the live from the pull cord into the neutral to the shower, neutral from the pull cord into the live of the shower. So when we done R1, R2 at the shower, really we was going between R1 and RN, so we wasn't getting nothing. So we'll fix that while we're here. We'll retest an R1, R2 at the shower. We don't really want to leave it like that, so yeah, I'll get that changed. But it's just nice to find things like that, and it just justifies why we do EICRs. Alright, so we're just getting the downstairs lighting readings. The conservatory's fed from the switch, so that's the end of point. When we go on the, well, when we went at the switch and at the lights, we was only getting 120 odd volts. So that makes me think the earth's not being carried through. So we've took the switch off where it's fed from. Straight away, two of the cables come out of the two-way, so we've made that good. But also the earth on the feed-in's been cut off, and it's not been joined to the rest of the lighting circuits going out to the conservatory. So as soon as we connected to that earth, we're getting our 240 volts back. So that's something to keep in mind if you ever get like a lack of voltage at a circuit. Your earth might not be connected properly. So what we'll do is we'll have to strip that back and reinstate it into the circuit.
No, that's from previous quick.
How am I going to do it with adding?
Just call, video, then you can add people as well and think.
Max, get in.
You alright?
You alright, mate? Was that your? It looked like it's in your ear.
Oh, it's on.
We're just going to say congratulations. We just see it when.
Thank you. Yeah, I'm literally just in front of the computer, like hitting refresh.
I said I bet he's sitting there watching it click over.
Yeah, it's literally just ticked over to 100,000. I'm super happy.
Oh, well done, mate. You get your little plaque through.
I was worried it was going to happen in the middle of the night. I woke up at like 1:30 in the morning and I was like checking it, and I was like, oh, it's fine, we've got like 150 to go. I think I'll leave until the morning.
Oh no,
Well done.
That's great news, mate.
Thanks thanks to you guys as well for all your help. It's a team effort. So
Yeah, brilliant.
yeah. Oh, we're 100,002 now.
Yeah, let's all go home. We'll go have a beer, put your feet up.
Oh yeah, I think the champagne's going to be cracked tonight.
Definitely. All right,
We'll get back to work.
Yeah, we'll finish this EICR and yeah, just want to say well done, mate.
Awesome, thanks guys.
Cool.
See you
All right,
later,
catch you
mate.
later. Bye.
Good day.
He's happy.
Mate, he's sitting there clicking refresh for an hour. Right, back to work. Okay, so all the testing's pretty much finished. So we're just going to go around, check the last few bits to do the paperwork. So I'm at the gas meter cupboard. So we'll open that up and we can see gas is earthed. That goes back up. So I mean, that's an easy one. Cable's big enough. That's looks like a 16mm to be honest. The water's always the tricky one, but it's usually under the sink, so we'll go check there. Yeah, so there's a water bond just at the back there on the water pipe, so that's all good. So we've got a bonding in place, so we can tick that. Is it smashed?
Yeah. Only my protector. They had none on it. Damn it.
Alright guys, I hope that was useful. I went into a little bit more depth and hopefully you picked up some tips here and there. I know it's not sort of how everyone would do it, and I'm not trying to teach people how to do it that shouldn't be, but if you found it useful, hopefully you can take something from it, and I think it helped you out, didn't it?
Yeah, massively, massively.
So yeah, and hopefully if there's any sort of clients watching, then it sort of shows them a bit more in depth of how we do things. If there's any clients or customers watching, hopefully they can sort of see it's a bit more involved than what they think. We'll have to sort of turn power on and off, investigate things a little bit, and it's all for their benefit. We're finding stuff that's wrong with the property. So yeah, thanks for watching and we'll catch you on the next one.